In this video, we are going to look at the ovarian hormones as well as the ovarian cycle. So the production of the hormones from the ovary are shown in this graph at the top of your slide. So we can see rising and falling estrogen and progesterone levels. Those are going to be responsible for causing the endometrium to change within the uterus. And that's specifically called the stratum functionalis, that top layer within the endometrium. So the cycles don't always last exactly 28 days. They're just shown this way for consistency, but there's only about 15, 16% of females that actually have a 20-day cycle. Most are going to range from 21 to 40 days, but the part that is consistent is the luteal phase. It's going to be 14 days after ovulation. So the follicular phase may be longer. So basically, what's going to happen here is the growing follicles are going to start to secrete more estrogens. And this initiates a positive feedback cycle with LH, and it causes the LH surge, which we're going to see in a little bit. Then during the luteal phase, which is right here, is where there's going to be an increase of progesterone and estrogen secretion by the corpus luteum. So that's why it's called the luteal phase. It's named after corpus luteum. The first part of the ovarian cycle would be the follicular phase. So the follicles that are going to secrete more and more estrogens. One becomes the dominant follicle towards the end of the follicular phase. So if we look a little further down at the bottom of this slide, we see the two consecutive phases. And now what is being shown in this graph is the development of those ovarian follicles. So there is early on development of primary and secondary follicles. Those are going to start to develop. The FSH levels are going to select a dominant follicle. So again, that's why it's called follicle stimulating hormone, because it selects the dominant follicle. Then towards the end of the follicular phase here, the LH is going to trigger ovulation of that dominant follicle. So here, the secondary oocyte is going to be ovulated, which is haploid. So it has completed meiosis 1. When there's a primary oocyte, it's still going to be diploid. So the LH surge then is also going to trigger the formation of this structure, which is the corpus luteum, and that releases progesterone and estrogen. So the corpus luteum is going to continue to produce those hormones to supply nutrients to the developing embryo if pregnancy continues. However, if pregnancy does not occur, the LH levels are going to fall and the corpus luteum is going to degenerate, and it degenerates into another structure, which is called the corpus albicans, and is scar tissue that remains in the ovary. So during the follicular phase, there are, again, several follicles that become sensitive to FSH. One dominant follicle becomes sensitive and is selected. That dominant follicle outcompetes the other follicles and is the only one to continue. The others are going to die with programmed cell death, which is called atresia, so that primary oocyte completes meiosis 1 to form that secondary oocyte. Remember that primary oocyte was paused in prophase 1. Then after ovulation, the ruptured follicle is going to collapse. The antrum fills with clotted blood, thus becoming the corpus albicans, corpus luteum, not corpus albicans. The corpus luteum secretes the progesterone and the estrogen. So if no pregnancy occurs, the corpus luteum degenerates into the corpus albicans, which is a scar that remains. So again, if pregnancy does occur, the corpus luteum produces hormones that sustain pregnancy until the placenta takes over at 3 months. So the corpus luteum is important for that first trimester. This slide is showing the hormonal regulation of the ovarian cycle. And before puberty, the ovaries secrete small amounts of estrogen to inhibit hypothalamic release of GnRH. But as the puberty gets closer, the GnRH is going to be released to stimulate FSH and LH release that acts on the ovaries. So, interestingly enough, if there are low levels of fat and low levels of leptin, this is going to cause puberty to be delayed. So, on the next few steps, we're going to see this occur. GnRH first stimulates FSH and LH secretion. They stimulate the follicle to grow, mature, and secrete sex hormones. So the granulosa cells release estrogen. LH prods thecal cells to produce androgens, which are most all converted into estrogens. And we'll come back to this diagram in just a minute here. The next event is there's negative feedback that inhibits gonadotropin release. So only the dominant follicle can withstand the dip in FSH. So the other developing follicles are going to deteriorate here. Estrogen levels continue to rise because of the continued release by the dominant follicle. And this eventually triggers the LH surge, which is responsible for ovulation and the formation of the corpus luteum. So the surge triggers ovulation. This triggers the primary oocyte to complete meiosis 1 to become the secondary oocyte. Remember that it is arrested temporarily or paused at prophase 1. The secondary oocyte then enters meiosis 2, and it continues to metaphase 2, where it then is arrested or pauses again. So the oocyte then, when it's ovulated or released with this radiating crown, the corona radiata. So the LH surge triggers ovulation, formation of the corpus luteum. So shortly after ovulation, the estrogen levels are going to start to decline, and the LH transforms the ruptured follicle into the corpus luteum. So progesterone helps to maintain the stratum functionalis, which is the inner layer of the endometrium in the uterus. There's going to be declining LH, which ends the luteal activity and inhibits follicle development. So if no fertilization occurs, then the corpus luteum degenerates into the corpus albicans. So on this slide here, we're seeing the gonadotropin levels. And there's this increase in LH, which is going to, again, be responsible for triggering ovulation. There's also a small surge of FSH, but it's going to be the FSH here that is going to kind of pick a bunch of follicles here. Then there's going to be a decrease in it, and this is where the dominant follicle is selected. So let's go back to this slide here and look at those events. We can see GnRH traveling to the anterior pituitary gland to trigger the release of FSH and LH. FSH is going to be responsible for causing these cells to start secreting estrogens. And the LH is going to be responsible for ovulation, but it's also going to trigger androgens to be released, but all of those are converted to estrogens. There's a minor amount of androgens that remain in the female body, but very, very few. So this would be the earlier part, early and the mid follicular phase. This would be the late follicular phase right before ovulation, and then finally the luteal phase. That's that second part of the ovarian cycle. So the mature vesicular follicle now is going to be increasing the production of estrogens. Remember, this is also a tertiary follicle. Sometimes it's called an antral follicle because there is an antrum here, or what's called a Graafian follicle. So at ovulation, the LH surge is causing that follicle to rupture to release the ovulated secondary oocyte. And what the cells that you can see here are part of the corona radiata, that outermost crown, which is surrounding the secondary oocyte. And then the corpus luteum is going to remain in the ovary. It's producing progesterone, estrogens, and some inhibin.